you can see velocity time graphs. If this graph is parallel to time axis, what it denotes, children? With what velocity body is moving? This graph?
Uniform velocity.
Uniform, not changing. Velocity is not changing with time. That is uniform velocity graph. So velocity time graph for a body moving with uniform velocity is like this. What will be acceleration when velocity is uniform? Velocity is not changing. What is the acceleration, children? Velocity is not changing. Change in velocity by time is acceleration. If velocity is not changing, what is acceleration? Zero. Acceleration is zero. So, when a body moves with uniform velocity, for example, a car always moves with a velocity of 80 km per hour. Is it having acceleration? Always moving with 80 km per hour. Car is moving with 80 km per hour. Not at all changing, decreasing or increasing the velocity. Is there any acceleration, children?
No, ma'am.
No. So what can you say about its acceleration? Acceleration is
Zero.
zero. Acceleration is zero. So such a body's motion is shown here. Suppose here you write 80 kilometer, time 1 hour, 2 hour, 3 hour passes, but 80 itself velocity is maintaining 80 kilometer per hour. So no acceleration or zero acceleration, and the graph is parallel to time axis. Then what type of motion is this, children? Is the velocity increasing with time? This one?
Yes, teacher.
Yes. See, time increases, velocity increases. Time increases, velocity increases. So, and it is uniform also. Uniform increase in velocity. So, is it accelerating?
Yes, teacher.
Yes, well, acceleration, that means velocity is increasing. So, we call it as positive acceleration. Velocity is increasing. So, it is positive acceleration. Then I will ask next one. Is it positive or negative acceleration? This one, velocity is decreasing with time. 1 hour.
Negative.
Negative.
0 time it was having maximum velocity. Then 1 hour velocity decreases. 2 hour velocity decreases. 3 hour velocity. Then 4 hour it becomes 0, like that. Velocity is decreasing. So negative acceleration it will be. Negative acceleration. Decrease velocity becomes 0 at last. So that is negative acceleration. So looking the graph, you have to tell. See, downward, the line is downward. You can see it is negative. Upward, you can tell it is a positive acceleration. Then position time graph. See, if a parabola is upwards, the curve is upwards, xt graph. See, children, it is not vt graph, it is xt graph. In an xt, if an xt graph is plotted and if we get a curve upwards, what it shows? What it shows? Positive acceleration. If the curve is downward, what it shows?
Negative acceleration.
Negative acceleration. If xt graph is a straight line inclined to time axis, what type of motion? What type of motion? Uniform?
Uniform motion.
Uniform velocity, uniform motion, we can tell. But at that time, is the velocity increasing? Uniform motion? Uniform motion, body moves the constant velocity. Is the velocity increasing?
No.
No. No change in velocity. That means no acceleration. Zero acceleration. So, if you see a graph, position time graph like this, you should be able to tell, yes, this body is moving with uniform velocity. So, no acceleration. Body is having zero acceleration. That is importance of this graph. Just by seeing the graph, you are able to tell, this is positive acceleration, this is negative acceleration, and this is zero acceleration. Body is moving with uniform velocity. Just like that, you should be able to tell. Negative, and just by seeing it, you will be able to tell, this is negative, velocity is decreasing, negative acceleration. So that is the importance of the graph. Just by seeing the graph, you are able to tell what type of motion the body is having. That is the importance of graph. Then I told you certain equations are to be studied to find to study the differentiation. Okay. That is what we are going to discuss today because that is important. Because differentiate the following with respect to x. This is a new thing, and beginning you may feel difficult, but you know when you do some problem, it becomes easy. Only 2 or 3 problems are needed to understand it well. Okay, so listen very well. Here some formulas. Have I given the formulas, children?
Yes, teacher.
Yes. So in that I told derivative of a constant is 0. Derivative of a constant is 0. So a constant number is given. Numbers are constants. 2002. And you have to you have to differentiate that with respect to x. D by dx means first differential coefficient. D by d, it is when you tell multiply, just like that it is a function. You have to do this process. D by dx, first derivative. Derivative of 2002. What is derivative of a constant is 0. That formula we have studied. That is what we have applied here. Derivative of a constant is 0. Another one, pi square. Pi is also another number. It is a constant. So derivative of pi square is also 0. If I ask derivative of 6, what is it, children? D by dx of 6, what is it? 0. D by dx of 6 is 0, constant. Then another, that is first formula we applied. Next formula, differentiate the following with respect to x. X raised to 6. A quantity x is having a power 6. Power, in a quantity involve power, how will you differentiate that? That means, see here y is equal to x raised to 6, that is given. So dy by dx, left side differentiating dy by dx equal to d by dx of this function, you have to write x raised to 6. D by dx, derivative, find the differentiate, d by dx. With respect to position dx, with respect to time dt. Here it is with respect to x is given. With respect to x. So d by dx you have to find out. D by dx of x raised to 6. And there is a formula d by dx of x raised to n. N x raised to n minus 1. N x raised to n minus 1. That is the formula. N is here 6. 6x raised to 6 minus 1. Then I will tell you how to do that, children, in your notebook. D by dx of x cube. What will be the answer? D by dx of x cube. All of you write. D by dx of x cube. Right, children? Right? D by dx. Take a notebook. Always keep a notebook with you. Rough book or notebook. Keep with you. D by dx of x raised to 3. Apply the formula and tell. Formula is n x raised to n minus 1. What is n here? X cube. What is n, children? N is the power.
3.
3. So 3 into x raised to what? N x raised to n minus 1. That is the formula. X raised to n. D by dx of x raised to n equal to n into x raised to n minus 1. Here 6 into x raised to 6 minus 1. So if it is 3, what is the answer? Please tell.
3x square.
3x square.
3x square. That is the answer. Understand? That is this equation we can do like that. 3x square is the answer. Similarly, y equal to 1 by x cube. When x cube is taken to numerator, it becomes
Negative 3.
negative 3. So y equal to x raised to minus 3. You do that. What is x raised to minus 3? When we differentiate, what we get, children? Find out. Find out. X raised to minus 3. Answer?
Negative
Negative 3.
3x raised to
X
minus
raised
4.
to negative 3, negative 1. Okay, minus 4. Correct answer. Who told that?
Nihal.
Nihal. Very good. So, negative 3 x raised to minus 3 minus 1. Minus 3 minus 1 is minus 4. See, minus 3 x raised to minus 3 minus 1. So, minus 3 x raised to minus 4. Next, you can see a function x cube is there, x square is there, 4 by x square is there, minus 8 is there. That you have to differentiate. So here, first you have to write differentiate with respect to x. So d by dx is what we have to find out. Now, y is given. Y is equal to, y is a function which varies with x. So y equal to 4x cube. Just we write that y equal to 4x cube minus 3x square plus 4 by x square minus 8. We wrote that. Then we find differentiate. Differentiate means d by dx with respect to x. D by dx of y, dy by dx. Y is equal to this function. So dy by dx, that means differential coefficient of y with respect to x, dy by dx equal to d by dx of, first we wrote this function. Fully we have wrote here. And we have written, fully it is written here. Next step you see, splitting each term, 1, 2, 3, 4 terms are there. D by dx of 4x cube, first term, minus, what is next term, children? Tell. D by dx of 3x
square.
Very good. Plus d by dx of
4 by x square.
x square. X square can be taken to numerator. X raised to
minus 2.
minus 2. Minus d by dx of last term
8.
8. That is written first. D by dx of 4x cube minus d by dx of 3x square plus d by dx of 4x raised to minus 2 minus d by dx of 8. 8. This term just we splitted. Each term is splitted. And then we apply the formula that we have studied. This is a constant. So constant into constant we are not differentiating. Take it outside. So if only constant is there, we write 0, derivative of a constant 0. Here only the constant is not there. Constant is multiplied with x cube. So that constant we write outside. Constant is taken outside 4. Then d by dx of x cube you have to write, minus 3 is taken outside, 3 into d by dx of x square. Then you tell this one, how will you write this? How will you write this? Constant take outside and tell. Please tell. No one is there.
2 by dx.
4 into d by dx of x raised to
Minus 2.
minus 2. 4 into d by dx of x raised to minus 2. Then last one you see, d by dx of 8. What is it, children? Derivative of a constant is
0.
0. So that we have written here. Next step, we are applying the formula d by dx of x raised to n equal to n x raised to n minus 1. N x raised to n minus 1. That formula we are applying, children. You have to tell. 4 into, 4 let it be there, 4 into, then x cube, what I told you, when you apply the formula, what it becomes? N, what is n?
3x square.
3x square, very good, 3x square. Then 3 into, 4 into 3x square it becomes, 4 into 3x square, that is 12x square. Then next term tell, 3 into d by dx of x square, how will you do? 2 into x raised to, tell, x square.
1.
2 into x raised to
1.
2 minus
2 minus 1, that is 1, x raised to 1. Why we get 3 into 2 into x raised to 2 minus 1. 2 minus 1 is 1 for 2x. So it will become 3x. 3 into 2x becomes 6x. Okay. Then last one, 4 into d by dx of x raised to minus 2. So minus 2, that is the power. N into x raised to n minus 1. Minus 2 minus 1. That is minus 3. 4 into minus 2, minus 8. Minus 8 into x raised to minus 3. That is what we are getting. 12x square minus 6x minus 8x raised to minus 3. That is the answer. So, we see, only we have used 2 formulas. Only we have used. and we need only that, children. So this one you can do, y equal to 5x plus 4. Children, do that. Y equal to 5x plus 4. You do that. I am not showing the answer. Do that. Y equal to, question I will show you. Y equal to 5x plus 4. Children, do and tell the answer. Got answer? First split cheya, then apply the formula. Vaishnavi, what is the answer? Vaishnavi. Vaishnavi. Varsha. Varsha.
Yes, teacher, I'm doing.
Doing only?
It's my net got reconnected.
Okay, okay.
Miss 5.
Teacher 5.
Ah, very good. 5. Very good. See, d by dx of 5x, first term. D by dx of 4, plus is there. Plus is there. D by dx of 4. And next 5 is taken outside. 5 into dx by dx. Dx by dx is 1 plus the derivative of a constant. 4 is a constant. D by dx of 4, that is 0. So 5 into dx by dx plus 0, that is 5. So this is the way to do the problem. Dy by dx equal to 5. I will give you homework, children. Then it will be easy for you. Then one problem, this type of problem is asked in our book, and all these type of problems you can see. A particle starts from rest with a uniform acceleration. Its displacement after t second is given in meters by the relation x equal to 5 plus 6t plus 7t square. Calculate the magnitude of its initial velocity and velocity at t equal to 3 seconds. Here x is the displacement. Displacement is given. And you are asked to calculate the magnitude of its initial velocity. If x is given, how will you find velocity, children? Dx by dt. That you should know. Velocity v equal to dx by instantaneous velocity v equal to dx by dt. So we have to differentiate this x with respect to time, dx by dt with respect to time, because delta x by delta t is average velocity. What is instantaneous velocity? Dx by dt. Limit delta t tends to 0, delta x by delta t, that is dx by dt. So we have to find dx by dt. All of you find dx by dt, children. With respect to t, you are differentiating. That is the only difference. Dx by dt equal to, right? Well, initial velocity v equal to dx by dt. First write. All of you write, children. Like this. Well, x equal to this given 5 plus 6t plus 7t square. Velocity v equal to dx by dt. Velocity v equal to dx by dt. Then I will not show. You have to do it. No points. First write this equation. First write this equation and you have to do it. 5 plus 6t plus 7t square. D v equal to dx by dt. ഇവിടം വരെ നിങ്ങൾ നോക്കി എഴുതിക്കോ. ബാക്കി നിങ്ങൾ നോക്കാൻ പാടില്ല. dx by dt. d by dt of 5 into 6. 5 plus 6t plus 7t square. All of you do it. Did you write this equation, children? Did you write? Why no one answering? Write this equation, Parvati.
Yes, teacher.
Then write dx by dt. All of you find dx by dt. Answer കിട്ടുന്നുണ്ടോ നോക്കി. Find dx by dt. I will give you 1 minute. 1 minute is enough.
Miss, finish.
Very good. What is this answer? 6 plus 14t you got?
Yes,
Yes.
teacher.
Very good.
Yes, ma'am.
How many of you got? Please tell your names.
Yes, teacher. Give me one.
Parvati.
I don't got.
Parvati Umesh.
Parvati got. Okay. Nayana, you got answer?
Yes, teacher.
Okay, very good. So I will show those who didn't get the answer. Please see the steps. First, x is given, velocity is dx by dt, first derivative of position with respect to time. So we have to differentiate this function, and here also it is a t, you know. So differentiating with respect to t we are doing. D by dt of 5 plus 6t plus 7t square. Then split each term, d by dt of 5 plus d by dt of 6t plus d by dt of 7t square. Then derivative of a constant is 0. 6 is taken outside, dt by dt plus 7 is taken outside, d by dt of t square. Then we apply the formula nx raised to n minus 1. So here 6 into dt by dt is 1, so it is 6 plus 7 into d by dt of t square, nx raised to n minus 1, 2 t raised to 2 minus 1. 2 minus 1 is 1, 2t. So 7 into 2t becomes 14t. So 6 plus 14t. For then question velocity we got, but question is initial velocity. What is the initial velocity? Initial velocity t equal to 0. Time t equal to 0, what is the velocity? That is the initial velocity. So in this equation, when you give t equal to 0, what is the formula, children? V equal to 6 plus 14t. T equal to 0, this term becomes
0.
0. Then what remains?
6.
6 plus 40.
14
6,
into 6 only. 6 only. So 6 is the unit you have to write. 6 meter per second is the initial velocity. Then one more part is asked. At a time t equal to 3 seconds, what is the velocity? Can you tell? Time t equal to 3 seconds, what is the velocity? 6 plus 14? 14?
42.
14 into 3. About 14 into 3 it will be 42 plus this will also be there. 42 plus 6 will be
40
48.
unit
meter per second.
meter per second. Like that you have to do. So first when x only is given, position is given, you are asked to find velocity. So you have to find dx by dt. Then you are asked to find initial velocity. Then you should know initial velocity is when t equal to 0. So substitute t equal to 0 in the equation and you will get the answer for initial velocity. Then one more part is there, that is at time t equal to 0, what is the velocity? T equal to 3, what is the velocity? So substitute t equal to 3 in this equation and find the velocity. That will be the expression for equation for or value of velocity, 48 meter per second. If anybody is having doubt, children, you can call me. When you are free time, teacher, I didn't understand. Please explain. Video call you can call or audio call you can call or anyway, the only thing is that you have to understand the things very well. If any question of this type come for exam, everybody should be able to do. I didn't understand physics. I don't understand. Don't tell like that. Put some effort in understanding things. You must take effort, children. Teachers are ready, but why you are not calling teacher? Why you are not asking doubts? Teachers are always ready. You have to put the initiative. Okay. Then acceleration is also asked, I think, in that question. Let us see that question once more. Initial velocity. See, uniform acceleration is also asked. Uniform acceleration. What is the expression for acceleration, children? We have just discussed that. What is the expression for acceleration?
Delta V by delta T.
That is average acceleration. Here, if it is not mentioned average, you have to see that it is instantaneous. So, what is the expression for instantaneous acceleration?
Delta V by delta.
Delta V by delta T is average acceleration. What is the equation for
When the
this?
limit is 0.
Limit delta T tends to 0, delta V by delta T. There is a short form of that. What is it? In terms of derivative, dV by dt. Very good. Very good. dV by dt. So you have to find dV by dt. V is this. V is this. All of you find dV by dt, children. Acceleration A equal to dV by dt. Very easy. One step only. dV by dt find out. dV equal to this. dV by dt equal to d by dt of 6 plus 14t. Fast. All of you find dV by dt. This is a 2-mark question, very important also. V equal to this, dV by dt, left side, d by dt of 6 plus 14t. Got? Derivative of a constant, d by dt of 6 plus d by dt of 14. Derivative of a constant 0, 14 into dt by dt. What is dt by dt? dt by dt is 1. So what is the answer? See, 1 second is enough. Got?
14.
14 are correct answer. Those who did not understand, I will explain. We know 6 plus 14t. So its question is, what is acceleration? Acceleration is instantaneous acceleration is dV by dt. So d by dt of v you have to write v 6 plus 14t. Next we are splitting the two terms, d by dt of 6 plus d by dt of 14t. Then we know derivative of a constant is 0. Then 14 is a constant, so it is first taken outside. Then we have to write dt by other function. You are writing dt by dt. dt by dt is 1. So what remains? Only 14. 14 into 1, 14. And unit is meter per second square. Then at t equal to 5 seconds, what is the displacement? That is asked. That is also asked. So in displacement equation, give t equal to 5. Displacement equation is given. First quantity given is that displacement equation. And what is the displacement at t equal to 5 seconds? So in the place of t, you have to write 5. Then you will get the equation for value of displacement at t equal to 5 seconds. So this is this is a 3-mark question. 3 parts, many parts are there. First you have to find velocity, then initial velocity, then at t equal to 3 seconds, what is the velocity, then what is the acceleration, and what is the displacement at t equal to 5 seconds. All things are asked. So 3 marks. Okay. A similar question is given here. See, x equal to 2 plus 5t plus 7t square. Calculate the magnitude of its initial velocity. Velocity at t equal to 4 seconds. Uniform acceleration, same way. That you can do as homework, or you can do it now. Which one you want? Homework? Children? Homework. Okay, understood now. So you can easily find out. Next, what type of motion is this, children? Tell from the graph. This is see velocity time graph. Just you look, first you have to look what is written, x-axis time, y-axis velocity, and at u at a particular value one straight line is drawn. That is our graph. What it shows? What type of motion?
Uniform.
Uniform velocity, uniform velocity. Time is passing, but velocity is not changing. Velocity is constant. If u itself, for example, u can be 50 meter per second. That 50, 1 hour 50, 2 hour 50, 3 hour 50, not changing. Velocity is not changing. That means uniform velocity. Is it an accelerated motion?
No.
No. No,
No.
no, velocity is constant, not at all increasing or decreasing. So it is a uniform motion, uniform velocity, zero acceleration. Understand? Acceleration is zero. And you are asked, what is the question? Draw a VT graph for a body moving with constant velocity and show that area under the VT graph equals displacement. You have to show its area under this shaded area. Area under this graph is equal to displacement, that you have to show. When you mark the area under the graphs, what is this figure? It becomes a rectangle.
Rectangle.
Yes, it becomes a rectangle. How will you find the area of a rectangle?
L into breadth.
L into B.
L into B, length into breadth. Here, what is the length? 0 to capital T, that is the length. And here, 0 to U, that is the velocity. What is velocity into time, children? Length into breadth, velocity into time, U into T. What is it? What is velocity into time? Displacement. Yes. So that is what you have to show here. Show that area under VT graph equal to displacement. So first you have to plot the graph and you have to tell the area under the graph is actually a rectangle, and for a rectangle the area is length into breadth. Here the length is T, time interval, capital T minus 0, and the breadth is U minus 0, initial velocity minus 0, that is U. Here it is T. So U into T, velocity into time is displacement. Only that you have to show. That is U into T. Therefore, area U into T, which is the displacement in this time interval. That is what you have showed here. It is also a 2-mark question. Show that area under the graph. Area under VT graph gives what, children? Area under VT graph gives what?
Displacement.
Very good, displacement.